once we've defined our class and created our initializer, how do we go about creating an instance of that class object? The syntax of this holds a few things in common with the previous way that we've created instances of built-in data types. That is, the name that we would like to give to the variable is going to be written on the left-hand side of an assignment operator. And what goes on the right-hand side of that assignment operator is different than if we were using a built-in data type. The first thing that we write down is the name of the class we've defined so that the computer knows what type of object we would like to make in creating this variable. So this almost has the look of casting an object as a particular data type. So the class name goes here, and inside those parentheses goes a list of the different arguments that you would like to pass in to the initializer to take the place of the various attributes of the class. So you can see that down here with the point example, our initializer tells us that we have two attributes, both an X position and a Y position, to the point data type. So when we declare a point later on called myPoint, we assign it the value of the point class type with an X position of 3 and a Y position of 4. Just to be very explicit, notice the difference between the definition of the initializer and the call to that initializer. The word self is written here as the first argument to the initializer function, but we don't use 3 arguments when we call the function. That self piece that's written right here is missing from when we actually create an instance of the class data type. The reason for this word self in all of the methods that you're going to define within your class is very simple. In particular, we need to go where in memory to create these variables and store them. At the time that we are defining the class, we don't know what the name of the variable is going to be. And in fact, that's probably going to change as we create several instances of the class. So what we're actually accomplishing with this reserve word self in Python is that we're telling the computer to take whatever object it is, which we reference as coders by its alias, this myPoint name. And what we're actually doing is telling the computer to use the identification of the slot in memory of whatever variable is being created at that moment in time. So that word self is telling the computer the exact location to access in memory, which is how the computer accesses the spot anyway. And when we want to access that spot, we will generally call it by its alias, and the computer will make that translation from myPoint to self anyway. So the short version of that is that you need the word self when you're creating all these functions inside of your class, and that's a word that's only used when you're creating and defining a class, not when you're using the class. That's the short version of the argument on the self reserve word. I'd like to go one step further with discussing how we use the attributes and methods of a class, and this is something we've actually seen before. We access both the attributes and the methods of a class with the dot notation. And I've given one example of what's going on here below and wanted to relate that back to the scope discussions we've been having. If I create a variable called X position and give it a value of 3, I can then create an object called myPoint, which is a point data type that has as its X position whatever the contents of this X position variable is, and a value of 4. So if this is the first line of code and this is my second line of code, at this point in the flow of control of the program, myPoint has an X position and a Y position. The X position is 3 and the Y position is 4. When we then progress to the third line of code and we reset the value of x position, this global x position will have its value changed from 3 to 5. But this global x position is not the x position variable of any points that I have created inside of my program. In particular, the x position that's associated with this specific instance of the point class is found by accessing myPoint.xPosition. That's the full name of the variable that's associated with myPoint. So if I ask the computer in line 5 here to print the value of x position and myPoint.xPosition, this change to the global x position is not registered by myPoint's x position. If I do want to change the value of myPoint's x position, then I need to do that by calling it by its full name, myPoint.xPosition, and assigning it a new value. At that point, if I ask the computer to print myPoint's x position, it will register that change made right here in this line. One thing I don't have written down, but is a useful thing to know about accessing the attributes and methods of classes, x position is an attribute of myPoint. We also had a method of the point class, which was that distance method, and because that is a method or a function and not an object, if I were to call myPoint.distance, I would need to follow the distance with that open and close set of parentheses, because that's the way that I make function calls, whereas when I'm just accessing objects, I don't need that open and close parentheses. So if you've been wondering that about other modules or libraries, why do we follow some things with parentheses and some things without? What's going on there is the difference between referencing an attribute, no parentheses, and referencing a method, parentheses. Last but not least, I'd like to return to that self-reserved word. The code right here shows how to access the attributes of a particular instance of a class object. How do we access the attributes of a class object within the class? For example, when I'm creating that distance method, how do I reference this particular instance's x position and y position? What I want to do is use the same notation that I would be using up here when I have the name of my instance, but because I am lacking that name of the object, I'm going to use the same trick I used before, which is to use that self-reserve word to exchange the variable name with the actual location in memory of the instance that's occurring. So I use that self keyword in place of a variable name when I don't have a variable name to exchange the variable name with the location in memory.